Well, hello everyone, and welcome back to Adrian's Digital Basement 2. We're going to be talking about the TRS-80 Model III here. This is a companion video to the video that was released today on me fixing this motherboard. Specifically, the focus of this video is going to be on the diagnostic ROM that I used to fix this machine. Since shooting the footage of repairing this motherboard using the diagnostic ROM, major enhancements have been made to the ROM that didn't make it into that original video, which I wanted to show off on this video here to kind of give you a tutorial on how to use this ROM, first of all, if you are trying to fix your own TRS-80 Model III and potentially the Model 1. So this machine, as I said, is working. It's actually currently powered up and I am capturing the video output right there. And yes, I have a webcam hooked up. It's terrible quality, but I have a little talking head in the corner. So there is the cassette prompt, which is this system booted up. Now on the TRS-80 Model III, there are 3 ROM chips. This is the primary ROM chip right here, which actually bootstraps the entire system when you first power it on, and these other 2 handle other stuff. The diagnostic ROM we've created runs in this ROM socket here, which is called ROM A on the schematics. These 2 do not need to be in the machine for it to work, but let's take this out, and I'm just going to use, let's see, something appropriate to pull this chip out. Now, I talked about this again, and I think in part 1, or was it in part 2? I don't remember. This is a 2364 ROM chip, so this is a mask ROM. It is not pin compatible with EEPROMs. So to use a programmable chip like an EEPROM or an EEPROM, as in the case here, you do need to use a little adapter PCB. Now this is one that I got from PCBWay. I don't know who designed it, but it works really well at adapting 2364s and also 2332 sockets, and it even works in 2716 sockets and various things that have similar footprints, or pinouts that is, to work with 27128 EEPROMs, and there's a jumper here you can install to kind of run the top half or the bottom half. It also can run with 2764 EEPROMs, and in here right now is a 2864B, which is an EEPROM. I'm just going to plug the diagnostic ROM into the motherboard, leaving everything exactly as is, and let's plug it in. All right, so it did a quick video test right there, which you saw, and you hear the beeping. So changes since in the video where I repaired the motherboard are, it now tests for the Model 3. Okay, let me turn the volume down here because there's going to be a lot of tones. So let's talk fundamentally about how this diagnostic works. So the first thing it does when you power up the machine is it creates a beep out of the cassette port, just so you know that the ROM is running. If you don't hear that beep, there's either a problem with the audio output or the cassette port on the machine, which is possible, or it's not even executing code. If I took the CPU out, for instance, there would be no sound. But if I also took off this little ribbon cable right here, so if your ribbon cable is degraded, you might also have no sound. So that audio prompt is important. You hook your speaker up to the cassette port, which is this. The positive is the pin that is towards the back of the motherboard where this white connector is right here. And then you can just hook the ground up to like this ground lead right here. So the system beeps, and then it does a very thorough but quick test of the video RAM. There is only 1K of video RAM, so it's really fast and doesn't take very long to run. Originally, when we were testing the VRAM on that first ROM, the one I showed in my video, it was only testing very simple bit patterns, like alternating 1s and 0s and then just some particular patterns. That works, but it's very, very rudimentary. The new test that's on here now is using the March test. In simple terms, what a March RAM test is you fill up all the memory locations with a 0, and then you go through and read every location, and then you invert it and write that memory location back. And you go through all the memory and you do that twice. When you are done, you should end up with memory that is all 0s. And then you run the March test again, but you start with all 1s, and you invert that twice, and you should end up with all 1s. That is a great and very thorough way of figuring out if any bits are stuck at 1 or 0, or if writing to any one bit affects another bit. So if you're writing a 1 to, like, say, location 100, and it also affects location 200 and makes that a 1 as well, then what happens is by the time the test gets to that second location, it's going to flip it the wrong way. And when you are done with the test and you're looking for all 0s, you're going to have bits that are stuck at 1. That is the memory test that we are now running for the video RAM test because it's extremely thorough. Next, once the VRAM test is done, then we use that video memory, which is just memory mapped RAM, as the stack pointer for the processor. And that's important for us because the routines that we're using to print text to the screen and do other stuff in this bigger memory test really requires the stack. Now, of course, I'm still talking about the video RAM test. We haven't even got to the DRAM test. And what that means is you could have no memory in this machine whatsoever, or the memory could be broken, and the diagnostic will still be able to boot the machine and then come up with text on screen, kind of like what you're seeing now, which is very, very helpful. It's not like other RAM tests that don't work at all without actual working memory. Incidentally, that's a difference between the Z80 processor here and the 6502 that allows you to set the stack pointer to any arbitrary location in memory that you want. The 6502, on the other hand, is always at location, I think, 100 hex for the stack. So if you don't have working DRAM at 100 hex, you're not going to have a working stack, which means you're going to have trouble running certain subroutines and other things inside your program. Okay, so at this point, the diagnostic has found that the video RAM is working perfectly, so it's now time to test the DRAM. And that's what you see happening on the screen here. Now, it's running two kinds of tests. It's running a random number test, which is something that Frank came up with. Basically, he used prime numbers, and he is writing all these random numbers to memory, and then you want to read back the exact same string of random numbers. Again, on the first version of this diagnostic ROM that I was using to fix this board, the RAM test was very simplistic and was only just writing some bit patterns to memory, and it would just read them back one page at a time. The problem with testing memory like that is you can have memory chips that have page errors. And what that means is on a 4116 DRAM like these, you could write to one memory location in one page. And keep in mind, a page with these types of chips is 256 bytes in size. You could write to one memory location in one page, and it could affect the contents of other memory locations in other pages. I had a Commodore PET recently on the channel. It was a 4016 machine, and it had a fractional RAM value. And that machine, I don't want to spoil it if you haven't watched that video, but the problem on that machine was simply that one of the RAM chips had this exact page error, and it would obliterate the stack. Commodore's diagnostic routines are too simple to detect those types of problems, and as soon as you have problems where the stack is getting overwritten by page errors in the RAM, it causes programs to behave very unpredictably and crash, which is exactly what was happening on that Commodore PET. These new diagnostic routines, as you can see on the screen here, is running random tests that Frank wrote, and in addition it's also doing March tests that David wrote, so it runs both kinds of tests here. It doesn't even bother to run those simple bit pattern tests anymore because they're just not that robust compared to these ones. So as you can see on the screen, it's been running the whole time I'm talking. It's tested the VRAM, it's working well, and now it's going through and it's testing all three banks of memory that are on this machine, and then additionally it tests the entire memory location. Now, that's probably superfluous. We don't really need to do that because any kind of RAM errors you're going to have on any chip, it's not likely to affect another bank. It's possible because maybe it's holding the line low or something like that. But to be honest, if that's happening, you're going to see that there's going to be bit errors in all three banks, so we don't really need to test all of it together. Now, keep in mind that the bank size on this machine right now is 16K, because each one of these banks is holding 16K of RAM. This motherboard, through jumpers, also supports 4K RAM, where you can have a total of 12K as opposed to the 48 that are on here now. There are going to be two versions of the diagnostic ROM for the Model 3, one set for 16K banks and one set for a 4K bank size. So, if you're going to download this ROM, please make sure to download the correct one. In addition, there is going to be a Model 1 version of this ROM, but that's not ready yet, and that's due to the fact that the Model 1 architecturally is the same as this machine, except in a stock configuration, the Model 1 only has 7 bits of video memory, not 8, which means we are unable to use the video RAM for the stack memory on the Model 1. So we're going to have to rely on the DRAM, or maybe David can come up with a way of changing the routines where it doesn't rely on the stack at all for doing a DRAM test. Or possibly we can test part of the DRAM, like one of the banks of the DRAM, using a stackless test. And if that passes, then we can point the stack over to that part of the memory, which would allow us to then run the rest of the diagnostics normally. Now, some Model 1s have a mod that allows lowercase, which involves adding an extra chip for 8 bits total of video memory. Those ones are going to be able to run this diagnostic pretty much as is without any problem. So if you know for sure that your Model 1 has that extra RAM chip, then go ahead and just use the Model 3 one and it will work. Keep in mind, of course, that most Model 1s only have 16K of DRAM on the machine, but it might also have 4, and then the expansion interface has different amounts of memory on it. And what I'm not sure about is if you can have 4K on the Model 1 and then have like 32K in the expansion interface, if like those two different bank sizes are compatible with each other, and if there's a gap in memory and all that stuff, I'm not totally sure on. I have a Model 1 that's got 16K in it, and I have the expansion interface, which has an extra 32K, so that brings up to a total of 48, exactly like the Model 3, and this ROM that's running right now on this machine should just work on that machine. I haven't yet tried it because that whole computer is falling apart. Unfortunately, the ribbon cable in it that connects the ROMs to the motherboard, because there's a level 2 ROM upgrade, is corroded and falling apart, so it does not work reliably. Okay, so I just turned the speaker up, and you will hear, after each of these tests, you're gonna have like a rising tone to say that it's working. If it goes down, then, I was waiting for that to finish, that is a bad RAM test. So, I'm gonna turn this down a little bit because it's distracting. Okay, so what I'm gonna do is while this system is running, I'm gonna be rude here, and I'm just gonna pull out one of the chips here. Let's finish. It's gonna start testing bank 1 again once it's doing the full RAM test here, which it's almost done with. There it is. Now it's testing the first bank. Plop that chip out of there. Here we go. It's gonna fail on bank 2, right? Because that's the chip I just took out. All right, you hear that? Has a downward tone. All right, turn the volume down so I won't be distracted. So take a look at that. So we are seeing a bit pattern now. And I think actually David has, since this video, there's actually an improved version even from this that I think tells you exactly which bit. Like it will say bit 6 is bad. But what you're seeing there now is a bit pattern. And this is bit 0, 1, 2, 3, 4, 5, 6, 7. And that means that the chip that I took out right now is bit number 4. And when you look at the diagnostic screen there, you'll see that it's 0, 0, 0 because those are good. This one is the problem bit. And then all of these are 0 because they're good. Now, if I just pull out another random RAM chip here while it's running, I know that's very rude, but I've done that a lot on this machine and it survives so far. It's gonna start finding more bad memory location. So here we go. So there it is. So now the C bank, that's the third bank, is showing that this chip is bad. It's pretty great. What I'm gonna do is we're gonna make a little documentation will be uploaded with the ROM, and I'll have a little map of the memory that just tells you which bit is which, so you can quickly figure out which chip is being pointed to due to a bad memory chip. Okay, so actually take a look at this. Notice that Frank's test, IZ8 DWF random, for the full memory location, that's the fourth line there, is only showing this chip as bad, or this bit as bad. It entirely missed that this one is bad. Now I think that's happening because his test routine kind of aborts as soon as it finds a bad bit. It doesn't go through and find the rest. But the March test, on the other hand, I actually had David write it, where it finishes testing every location and it reports on every bit that it finds as bad. So that's why on the fourth line there, and it's just testing right now, once it's done testing, it will show that both of these are bad. And come on. And there it is, 0, 0, 0, 1, 0, 1, 0, 0. So you can tell that it's these two bits that are wrong. All right, I'm gonna kill the power on this because I don't wanna put the chips back in while it's powered up. I mean, taking them out is one thing, but putting them in is pretty rude. All right, so this IC right here is the one that I had in that Commodore PET, the one that has the page error. Now, in that original diagnostic ROM, the one I showed in the video where I repaired this, when I put this chip in there, it actually did not detect a RAM error at all. And it's that exact problem because this only has a page error, but each page actually works on its own. It's just that the pages interfere with each other. So that's when I asked David to enhance this particular RAM test because I knew that it would fail with this bad RAM chip in. But I just popped it in. Let's power the computer up here. Here it goes with the testing. I'll turn the volume up so we can hear that. So this is in bank 2, and of course it's bit 4 again. Let's see what happens. Okay, so the random test detected it, and the March test will as well. There's the March test. There are some, I'm going to turn the volume off again. There are some situations where the random test might potentially miss something, and the March test is really, I think, pretty much the most reliable RAM test that exists, really. Okay, so next up, I'm going to pull out this bus transceiver. This is the one that was problematic in the repair video. That's going to kill 4 entire bits for all of the DRAM. This fault will not be difficult for this RAM test to detect because, as I showed, it's pretty good at detecting stuff. Let's plug it in. The computer will work though. If I have the stock ROM back in the machine though, it will not work because the stock ROM needs the first bank of memory to be fully operational for the system to get past that garbage screen that you saw like when I first started troubleshooting this motherboard. All right, so there you go on the diagnostic. It's failing on all of them. In fact, oh, and look, it's funny actually. So there's the problem again with the random test that Frank wrote. If you look at the second line, the leftmost one there only shows that these 4 bits are problematic. But remember, I have this bad RAM chip in there as well. But it does show up as all 5 chips being bad here, these 4 because it's missing the transceiver here, and this bad RAM chip on the March test. Please don't think badly of Frank's RAM test. It's very good. It's just, it exits out as soon as it detects a single bit error, and it would need to run through its entire loop for it to detect other potential bit errors. And of course, with this chip missing, all of these chips are in error, so it's like aborting instantaneously. All right, so I put the bus transceiver back in, and I put that page RAM error chip right here. All the rest of the memory is gonna work. I'm gonna pull out the diagnostic ROM here, and I'm gonna switch back to the stock Model 3 ROM here. What I wanna show is that with this page error RAM chip in here, I am predicting that it's not gonna boot this system properly. Here we go. Okay, there it is. So it's not showing just pure garbage, so that's something, but as you can see, that's clearly not a working system. Oh, look, it just blanked the screen for some reason. It's the kind of random things that are happening when you don't have a valid stack pointer. And I don't know where it's configuring its stack pointer with the stock memory here, but this chip with page RAM errors is gonna like obliterate the stack pointer when other parts of the memory is written. So those are the kinds of problems that you can run into on a system like this if it's not booting at all and it has just garbage. Using the diagnostic ROM is gonna very quickly and easily tell us that that is the bad bit, and there it is. Already instantaneously, we know that that chip is bad. All right, so let's back up a little bit and let's look at the video section of this board. The diagnostic ROM is not gonna find problems like with the character generation or the video output circuitry. It's only gonna find problems with the video RAM and the chip select line and any of the logic that connects it together, so like these bus transceivers and things like that. If this transceiver is bad or this ribbon cable is bad, then it's not gonna be able to talk to this entire section of the motherboard, which includes the cassette port. But this is the transceiver right here that is used for the video RAM specifically and to talk to the video circuitry. If I take this out, it should fail the video RAM test, but we should still hear the audio cues that there is a video RAM problem. So let's just test that. All right, the speaker is turned up. Let's plug this in. That is the sound you're gonna hear when there is a video RAM problem. Now, notice that we're seeing all of little symbols or whatever. That doesn't matter. It's not even talking to the video circuitry right now. That sound we heard, if you power this up and you hear that immediate beeping sound, that means that it cannot communicate with the video circuitry or there's a problem with the video memory. Right now, we do not differentiate between like a bit error in the video memory, like even one bad location, or all of it being bad because we just haven't gotten around to it. It's actually our intent to augment this ROM a little bit more, and maybe by the time you see this, it will have been done, where it will beep out, kind of like the dead test cartridge on the 64 flashes out the bad bit of memory. Well, we're gonna beep out the bad bit of video memory so that you can hear that. And of course, we have to do that before we can initialize the screen, right? All right, so I happen to have a couple bad 2114 chips. So let's stick one of these in here. That one's backwards. That's not gonna work at all. Let's put that in the right way. I don't remember exactly what's wrong with these, but they definitely don't work, but they kind of work. So let's plug this in. All right, so you heard the beep, you heard the bad memory tone, and then what the Vram test does, besides make the bad memory tone, which you heard, what it does before it halts the entire execution of any more code is it redraws all the possible characters to kind of give you an idea of which video RAM chip is bad. And I talked more about that on the repair of this motherboard. I'm not going to delve too much into like trying to decode the way this pattern looks, but what it does is it's displaying all 256 ASCII characters starting from 0 all the way to 255. So you need to look at an ASCII chart of all of the characters that are possible and then kind of try to work out where you're seeing characters in the wrong place, where bits might be stuck, stuff like that. I talked about that again in the part 2 video where I repair this motherboard. Anyhow, let's put back in the working chip and we'll conclude this video because I've kind of been going on for long enough here. So there it is, test is working, VRAM is good, and let me turn that down because that's way too loud, and it's going to test all the memory well. So that is it for the diagnostic for this particular computer. I think it's very helpful, and especially for the Model 1. I actually have a Model 1 machine I need to do some work on that was recently given to me, and it's not working, and I think this diagnostic is going to come in handy. But that particular computer is only a 7-bit video memory machine, so we're going to have to come up with the diagnostics that doesn't use the video memory for the stack to work. So we have a reason to adapt this ROM to do that functionality. Now, personally, I'm really proud of what we've been able to accomplish with this diagnostic ROM. It's some really, really thorough RAM testing capabilities for Z80-based machines. Theoretically, with other Z80 machines, it would be possible to use these routines, probably with changes because the way the banks are laid out are going to be different, that the video memory may not be memory mapped like it is on this machine, but you should be able to slice and dice the assembly code to potentially work on some other machines. And I've already started the preliminary work of getting this working on the K-Pro 2. The K-Pro 2, not the later ones, but the earlier ones, has much simpler video memory that is mapped directly into the processor address space. Of course, it's bank switched because it does have 64K because it's a CPM machine. But we're going to try to adapt this code to relocate into a high bank of RAM so we can bank switch out the ROM chip and the RAM. And anyways, so that's coming. But I think there's going to be a lot of smart programmers out there that can hopefully take these routines that are in here and adapt them to other systems, other Z80 systems that currently don't have any ROM-based diagnostics. To me, a ROM-based diagnostic is the way to go. A machine like this, without working RAM and everything else that goes with it, cannot even boot to the basic prompt. And without that, how are you going to run any other diagnostics unless they're in the diagnostic ROM like this? So anyhow, that is it. Huge thanks to Frank for originally writing some of the diagnostic code, and then for David, who did the lion's share of the programming on this diagnostic ROM. Amazing work. I don't think he knew Z80 assembly at all. He kind of learned that all, and I didn't know it at all either, and I did a little bit of coding there, and we were working together on it to augment and enhance the capabilities, and this has gotten to where it is because of him and because of Frank, and it is amazing. So if you've watched my videos and you want to run this diagnostic ROM on your machine, on your Model 3, I would love to get feedback, especially if it's not working, or a Model 1 for that matter, and let me know. Maybe there's going to be bugs, things like that. I think we're going to put the code up on GitHub, so of course people can put in pull requests and, you know, put in issues and stuff like that. And I will definitely have links down in the description so you can download these pre-assembled ROMs and you can make these little PCBs. I'll have a link for that, and yeah. That is it. So if you found this video good, thumbs up. If you didn't, you know what to do. Thanks to my patrons. Their names are scrolling off the side of the screen. And yeah, that is going to be that. So stay healthy, stay safe. I will see you next time. Bye.